Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with 3.3. This is all about different types of angles between lines and parallel lines specifically. So this is kind of like the converse of 3.2. So 3.2 is saying if you have parallel lines, then the angles are going to be either congruent or supplementary. And this is going the opposite direction, which is saying if these angles are congruent or supplementary, then we can say that the lines are parallel. So it's basically you're going to solve them the same kind of way. It's not really that hard of a section, but it is kind of what it is. So we have a warm-up here. We have these parallel lines, and we have 60 degrees and 7x minus 3. What kind of angles are those there? It looks like they're matching. They're in the bottom right, bottom right. Those are corresponding angles. So I want you to go ahead and solve that and see if you are going to set them equal or add them up to 180. Go ahead and give it a try. All right, so you may recall that corresponding angles are congruent between parallel lines, so we're going to set them equal. So we have 7x minus 3 equals 60, and we just solve for x now. So we got plus 3, 7x equals 63. Next step is to divide by 7. We get x equals 9. And there's our warm-up. Okay, sounds good. So this is basically a very similar thing. These theorems in here are very similar to what we did before. Basically, it's just the converse, like we talked about. So if the alternate interior angles of two angles are congruent, then the lines are parallel. And same thing for alternate exterior angles. If those angles are congruent, then the lines are parallel. Consecutive interior angles, if they're supplementary, they're going to be parallel. And then the transitive property, if two lines are parallel to the same line, then they are parallel to each other. Okay? All right, sounds good. Let's move along here. So how do we prove that lines are parallel? Well, we're going to prove that lines are parallel by showing that the angles that follow the properties of parallel lines and transversals, okay? So, for example, if you have corresponding angles, they should be congruent, and then consecutive interior angles should be supplementary, that kind of stuff, all right? So, example 1, it says, apply the corresponding angles converse. So it says, find the value of x that would make m parallel to n. Okay, well, if those lines are parallel, then the corresponding angles should be congruent or supplementary. They should be congruent, so we're going to set them equal and figure out what value of x we get, and that will make the lines parallel, because it'll be, basically for these lines to be parallel, they have to have a value of x that makes it true. Okay, so now we got to solve for x. Why don't you guys pause the video so you can solve this. All right, we're going to subtract 3 from both sides, so we get 2x equals 71 minus 3 is 68. We divide by 2, and we get x equals 34 degrees. So if x is 34 degrees, then that would make those two lines parallel, because we would have, what, 2 times 34 plus 3, which would be 68 plus 3, which equals 71. So now we have, this is 71, and this is 71, so these are congruent. So that's kind of what we're doing here. So we're basically finding what value of x makes those equal, okay? All right, we have a checkpoint. See if you can do the same thing for checkpoint 1. Give it a try. All right, sounds good. So these are what kind of angles here? They are corresponding, they are matching. They're in the top left and top left right here. Top left, top left. Okay, so do we set them equal, or do we add them up to 180? We set them equal. So 5x minus 7 equals 98. If you want to pause the video and solve it, see how you do. All right, now we got to solve for x. We're going to add 7 to both sides. 5x equals 98 plus 7 is 105. Divide by 5. We get x equals 21 degrees. So that would be the value that would make this work. Okay. All right, got a couple more examples. It's actually a pretty short lesson, so let's change the color here. Okay, so yeah, this is kind of a weird thing. We have multiple intersecting lines here, okay? So in the figure, it says A is parallel to B, so let's label those. Those are parallel, okay? And we know that angle 1 is congruent to angle 3, okay? So these are congruent, all right? And we're trying to prove that x is parallel to y. Okay, so we're going to do a couple things here. We're going to work our way across the diagram here a little bit, okay? We need to prove, if we can prove that like angle 2 and angle 3 are congruent, that would actually work, and we would be able to say that x and y are parallel as well, okay? Because we have angle 1 and angle 3 are kind of far apart, so we need kind of like the angles to be on the same transversal, all right? So you'll see what I mean here in a second, okay? So what can we say about angle 1 and angle 2? Well, angle 1 here's the transversal here, this x, right? What kind of angles are angle 1 and angle 2 between parallel lines? Those are corresponding. So we know that angle 1 is congruent to angle 2 because they are corresponding angles, right? They are corresponding angles, which means they're congruent, all right? Now we know that angle 1 is congruent to angle 2, and we already know that angle 1 is congruent to angle 3. So now we can say, what kind of angles are angle 2 and angle 3? Well, now this is the transversal, this A right here, right? What kind of angles are those? We can say that angle 2 is congruent to angle 3 because those are alternate exterior angles. Okay, and now we can say, now we have angles x and angles y. We have this transversal right here, right? Now we can say that x is parallel to y because their alternate exterior angles are congruent, okay? All right, so basically if we can prove that any matching pair of angle relationships are congruent, then we can say that the lines are going to be parallel, okay? So I know it's kind of tricky, but yeah, this is not super easy to follow, but you guys are probably just fine, okay? Why don't you guys try checkpoint 2? We'll go through it in a second. All right, so we know now we're given that x is parallel to y, so we know these angles are lines are parallel, and we know that angle 1 is congruent to angle 3 again, okay? We're trying to prove that A is parallel to B. Okay, well, we're kind of going the opposite direction now. We're going from 3, we're going to go to 2, because this is a transversal crossing those two parallel lines. So what kind of angles are angle 2 and angle 3? Well, we can say that angle 3 is congruent to angle 2 because of alternate exterior angles. Okay, and then now we know that angle 2 and angle 1 are what kind of angles? Now we have this line crossing here. We have angle 2 and angle 1. Those are corresponding, so we can say those are congruent. Angle 2 is congruent to angle 1, and those are corresponding. Okay, and now we can say that A is parallel to B because the corresponding angles on A and B are also congruent. So we can say that A is parallel to B because the corresponding angles are congruent. Okay? All right, those last two are not as important as the previous examples, but hopefully that makes sense. Don't worry about it if it was pretty tricky, but thank you for watching. Have a great day, and we will talk soon.